Welcome to all. In this lecture, we will learn how to represent polynomial using linked list. We will also learn how to perform addition and multiplication of polynomials using linked list. What is a polynomial? A polynomial is an expression with many terms. For example, 5x plus 3x square plus 3x cubed plus 1. This is a polynomial. If you notice, in this polynomial, we do not have any special arrangement of the terms. We have written the terms of this polynomial randomly. We can rewrite it as 3x cubed plus 3x square plus 5x plus 1. In this case, the polynomial is arranged. Every term of this polynomial is arranged in the decreasing order of their exponents or in the descending order of their exponents. Now, why are we using, what is the significance of this arrangement? Why do we order the terms of the polynomial in the descending order of their exponents? Okay, why we do that? It is because if we are arranging these polynomials in this order, the operations such as addition of two polynomials, such operations will be very less time complex. So we will see that advantage while we move on to addition operation. Now we will see how to represent a polynomial using linked list. So in our example, the polynomial has four terms: 3x cube, 3x square, 5x, 1. So we have four terms. We are going to represent this polynomial as a linked list. In the list, we require four nodes. Each node represents each term of the polynomial. So, the first term of the polynomial is represented by the first node of our linked list. So, what should be the contents of each node of a linked list? So, each node should have an exponent part, a coefficient part, and a link part to save the address of the next node of the linked list. So, in this example, we can see that the first node has coefficient 3 exponent 3. It represents 3x cubed. The second node has coefficient 3 exponent 2. It represents the second term of our polynomial, 3x square. The third node has coefficient 5 exponent 1. It represents the third term of our polynomial, 5x. And the fourth term or fourth node of the linked list has coefficient 1 exponent 0 link null. So it represents the term 1x raised to 0. Since it is the last node, it will have no successive nodes. So the last node will have null as the link field value. This is how we can represent a polynomial using linked list. Now, how do we declare a structure? We require a structure for programming this thing because we are storing multiple data types or multiple data has to be stored in each node. So, we require a structure data type for implementing this thing. So, what are the contents of the structure? Float coefficient, int exponent, struct node star link. That is a self-referential structure, struct node star link. So we have declared the coefficient as a floating point value, exponent as an integer value, and link having the same structure of a node. It points to the node with the same structure. So it is important to sort the list before performing any operation on them. Now let's move on to how to represent a polynomial using linked list. That is, we will be getting user input. What are the coefficients? How many terms are there? What are the exponents? And after that we will be creating a new node, and after that we will insert the new node in its respective position. So these are the things we are going to deal next. So in the main function we have the initially we are going to create a linked list to store the polynomial. So initially head, the pointer which points to the first node of the linked list, will have null because initially the list is empty. Then we will print enter the polynomial. Then we will call a function create. Instead of writing that whole code in this main program, we are splitting it into different functions. So what are we going to write inside the create function? Head is equal to create of head. So the return value is head, which is the pointer to the first node of the linked list. Create is the name of the function which creates a linked list to represent the terms of the polynomial. Head is the pointer we are passing to the function as an argument. So let us see how the structure of create function looks like. How do we write that function? So we have the create function. The argument is the first node of the linked list. In this function, first of all, we will ask the user how many terms are required, how many terms are there in your linked list. User enters the number of terms. This value will be stored in a variable n. So let us assume that this is our console window and we have asked to enter the number of terms. The user has entered 2. Now the variable n will store the value 2. Then for I equal to 0, I less than n, I plus plus. Now we are going to accept the user input for the coefficient and exponent field of each term of our linked list. So printf enter the coefficient for term %d I plus 1. Why I plus 1? Because for the first iteration of our for loop, I is equal to 0. So we have to print something logically, isn't it? So we have to print enter the coefficient for term 1. So the user will enter the coefficient of the first term. So it is declared as a floating point value. We can enter 1.5 or 2.5 like that. Then user is asked to enter the exponent for the term 1. So for the first iteration of the for loop, I is equal to 0. So I plus 1 will print value 1. Then we have taken the user input. What is the exponent field of the variable? In this example, we are working out on a single variable polynomial. That is a polynomial with x, variable x. Okay. Then we will call, now we have the two values. I have the coefficient and exponent value for all the terms. In the first iteration of the for loop, I have the coefficient and exponent field of first term. In the second iteration of the for loop, we have the coefficient and exponent field of that is the actual values we have of the second term. In the third iteration, we have coefficient and exponent field of the third term, and so on. In this example, we have just two terms. So we have two terms. For each term, I will call a function called insert. Why? Instead of writing that code in this function or in the main program, we are writing these things as separate functions. Then the insert function is used to insert these values into a linked list and insert these values into a node and insert that node into the correct position in the linked list according to the descending order of their exponents. So the insert function has three arguments: the head, coefficient and exponent. Head is the pointer to the first node of the linked list. We have to pass that pointer because we need to append new terms to that linked list. And after creating the new linked list, we will return it. So when we are returning head pointer, we are returning the information of the complete linked list. So the return value of this function is the head pointer. Now let us see what does the insert function do. So this is the structure of the insert function. Insert function has three arguments. One is the head pointer, then the values. For each term, what is the coefficient value and what is the exponent value. Then we create a dummy pointer temp. This dummy pointer temp is used to traverse through the linked list. Next step is about creating the new node. Struct node star new p equal to malloc. This is the dynamic memory allocation function used to allocate memory to a node during runtime. Malloc size of struct node. Then we have created a new node. Now it is our turn to fill data into that node. For that, we use the statements new p, that is the name of that node, new p that is read as the coefficient of new p equal to co, that is the value we have. Exponent field of new p is equal to ex, that is the exponent value we have. And we have created one node, and we are storing null as the link field of that node. So we have created a node and we have entered the values into that node. Our next aim is we have to add this node to our linked list. So initially we are checking whether the linked list is initially empty. Head is equal to null. It means that the linked list is initially empty. So if the linked list is initially empty or the exponent value of the new node is greater than the exponent value of the first node of the linked list. What does it mean? Let us suppose that the new node is 2x raised to 5. The existing node at the front of the linked list is 2x raised to 3. So it means that exponent field of the new node is greater than exponent field of the existing node at the front of the linked list. What does it mean? Initially, we have mentioned some significance of storing a linked list in ordered manner in the descending order of the exponents. To keep that order, we will add the new node at the correct position in the linked list. So, if the exponent field of the new node is greater than the exponent field of the first node in the linked list, it means that the new node must be inserted before that first node. So we will append the new node at the front. We have already discussed the algorithm to insert a new node at the front of a singly linked list. So that is these statements. So we have a new node, we have to append it to the existing linked list. For that, we will create a link from the new node to the existing linked list. That is link of new p. That is the link field of new node. We will write the address of the existing first node in that place is equal to head. Then now which is the first node? Yes, new node is the first node. So we will reassign head to the new node. That's it. Otherwise, else. That means the linked list was not initially empty and the new node's exponent is not greater than the existing front node's exponent. Then what is to be done? We have to find the correct location of the new node and insert that new node there. For that, we require a pointer variable temp, that is a dummy pointer used to traverse through the linked list. We will traverse through the linked list until we find the exact correct location of the new node. There you enter the new node. So we have learned the algorithm on how to insert a new node, in at any place in a linked list as a different lecture. So we have learned it in the previous classes. So this is that code. Link of new p is equal to link of temp, then link of temp equal to new p. So in the last step, we return the head pointer. So we have entered the value of exponent and coefficient for one term. Then we called the insert function. What does the insert function do? The insert function will insert the values into a newly created node. Then it will insert this newly created node to the linked list according to its correct location. So at the end, the linked list will be sorted. That will be arranged in the descending order of the exponent fields. For example, it will be like 5x raised to 5 plus 6x raised to 3 plus 3x plus 1. Okay. So these are the variables which stores the values of coefficient and exponents. So we took it as the user input. Initially, the head pointer was null before we create the linked list. So while we create the first node of the linked list, the head pointer must point to the first node of the linked list, and it will have the value of the coefficient and exponent in its coefficient and exponent fields. Next thing we are going to learn is how to print a polynomial. That is simply how to display the polynomial on your screen. So in a linked list, we have a polynomial. Now we have to display the polynomial. So what is the first step? First, we have to check whether the polynomial is empty. So how do we identify whether a polynomial is empty? If the head pointer is null, it means that the polynomial is empty. Otherwise, make a dummy pointer temp. Why we require that dummy pointer temp? We have a pointer head which points to the first node. But if we are using that pointer variable to traverse the list, we will finally lose that where is the first node located. We will lose that address. So to avoid losing the address of the first node of the linked list, we are taking a backup or a dummy pointer temp.